if there are some data or attributes that you really care about, then you should make them read-only. Let's consider an instance of our product. Product 1 equals product, the name of the product, and the price. With the current implementation, it is possible to read and modify the price of a product after it has been created. Let's try to access the price of product 1. Print product1 dot price. Now we are going to update the price. Product1 dot price equals 150. Print product1 dot price. The expected output now is 150. Let's run the program. We have 150 as the new price. The first problem with this approach is that an untrusted user can decide to manipulate this price to another value. This is possible because the user is able to modify the price attribute directly. The second issue is that a user can set the price to an invalid data type by mistake. Let's change the price to a string ABC. Let's execute the program again to see what happens. As you can see, it still works. You won't know there is a problem until you try to call a method where those values are used. Let's get the total price of this product. Print product1 dot get total price. Get total price. Get total price. Where is the method? We need to pass the quantity. Let's say we are buying 4. Now let's execute the program to see what happens. Before that, let's comment out this part of the code. Alright, so let's execute the program now. The get total price method returns an invalid value because a string data type was passed as the price. Sensitive data such as the price should be read-only when accessed from outside a class. To make the price attribute read-only, you can use a double underscore before its name. This convention signals that the attribute is intended to be private. Using double underscore limits direct access from outside the class. So now let's say self.double underscore equals the price that was passed. Now what we need to do now is to update our code base to reflect this new variable, double underscore price. We used the price variable here as well. Now this price attribute is private, which means it can only be accessed within the class methods. Let's pretend to access the price attribute from an instance. This is an instance of the class. Let's say product1 price. Let's comment out this part of the code. We are trying to access an attribute which is now private from outside the class, such as from an instance. Let's execute the program to see what happens. Python raised this error because this double underscore price attribute is now private, which means it can no longer be accessed from outside the class. It can only be accessed from the methods within the class. Now, the attribute we care about has been effectively hidden and cannot be accessed from outside the class. The next step is to use the @property decorator to create a read-only attribute. The name of the method will be the read-only attribute you want to create. Let's say def price, which is the name of the price attribute we want to create. Self return. You need to return the value of that attribute that is now hidden. Self.double underscore price. And the final step is to make use of a decorator @property. This attribute, which is price, is now a read-only attribute, which means we would be able to read the value of the price from an instance, but we won't be able to modify the price because it is a read-only attribute. So this is how you can create a read-only attribute in Python. Remember, price is a read-only attribute. Let's execute the program to see what happens. Great. We are now able to access the value of price. Now, what we want to do now is this. Let's try to modify the value of price. Let's say product1.price is now 90. Let's see what happens. Python raised attribute error. Attribute error. Can't set attribute price. We are not able to set attribute price because price is now read-only. You can only read the value. You can't set the value from outside the class. Sometimes you want to be able to set the price. This means you want your program to respond to something like product1 attribute.price equals 90. To achieve that, you need to provide a setter. Setters are just a way to provide more control over how we set attributes. First, you need to use the @ symbol. Then the name of the attribute you want to set. In this case, price.setter. Now you cannot specify the name of the method as price. Def price. It takes the first parameter as self, then value. Pass. The value you receive when users try to set the attribute is captured as value. The main purpose of a setter is to have control over what the user wants to set. You may want to put restrictions on what the user can set as the price, and so on. We want to be sure that the user is sending a number. If not, instance the value and the instance int floats. If the value the user is trying to set is not an integer or a float, then we want to raise an exception. Raise value error. Price must be a number. If value is less than 60, raise value error. Minimum amount is 60. Else, if all the conditions are met, we want to set the price value ._price equals the value. We have been able to provide a setter for price. Remember that price was read-only before. Alright, so let's go and try out this in our code. Product1.price equals ABC, a string. Let's execute the program to see what happens. As you can see, price must be a number. Now let's use a value which is less than 60. Let's say 50. Let's run the program again. We have the error, which is value error. Minimum amount is 60. Now let's use 90. Let's execute the program. So that's how we can make use of getters and setters. Getters are the same as the read-only property. That is, you are able to get or read the value, while setters allow you to set the value of a specific attribute. If you enjoyed this video, make sure to give it a thumbs up. Subscribe, like, and comment. Thanks.